Good morning, this is your Stat Sensei, Mr. Spensei, and this is Death Packet for Proportions Problems 91 through 100. So, for a certain population of men, 8% carry a genetic trait. So let's call that 0.08. For a certain population of women, 0.5%. Be careful. That is 0.5, which is divided by 100, is 0.005, because all percents are divided by 100. Let p hat 1 represent the same proportion of randomly selected men from the population who carry the trait, and p hat 2 represents the sample proportion of women uh, who carry the trait, not the train. For which of the following sample sizes will the sampling p hat 1 minus p hat 2 be approximately normal? Well, to be normal, n1 times p hat 1 has to be greater than or equal to 10. So let's go ahead and do that. We don't know what N1 is, but we know N1 times 0.08 has to be greater than or equal to 10. And if you take 10 and we divide it by 0.01, we get, oops, if we take 10 and divide it by 0.08, we get 125. So N has to be at least greater than or equal to 125, N1. Now we also need to check N1 times P hat 1 minus P hat 1. That also has to be greater than 10. So in this case, N1 times 1 minus 0.08 has to be greater than or equal to 10. So this is 0.92. Divide both sides by 0.92, and we have 10 divided by 0.92, and we only needed 11 on this side. So the greater number, this had to be n is greater than or equal to 11. The one we're worried about is this. So n1 has to be bigger than 125. Well, in that case, that gets rid of this problem, but all the rest of these are possible answers. The next one, we have the N2 has the same conditions. N2 has P hat 2 has to be greater than or equal to 10. And in this case, we don't know what N2 is, but we know P hat 2 is 0.005, has to be greater than or equal to 10. So dividing both sides, 10 divided by 0.005 equals 2,000. So I need 2,000 women. Well, the only one that has 2,000, that has at least 2,000 women is D. So 91 is D. All right, moving on. 92. In two common species of flowers, A and B, the proportion of flowers that are blue are P sub A and then P sub blue, B. Suppose that the independent random samples of 50 species of A flowers and 100 species of B flowers are selected. Let P sub A be the sample proportion of blue species and P sub B be the sample proportion of blue species, B flowers. What is the probability? What is the mean of the sampling distribution? Well, if we think about it as far as a confidence interval, we'd go, hey, the part in front of the confidence interval is the mean, and that's basically p hat 1 minus p hat 2. But they're talking about the mean of the sampling distribution, which means we're no longer talking about sample, we're talking about the population. So we need P1 minus P2, but they said, hey, it's not that, it's A and it's B. So the answer choice is PA minus PB. Because remember, whenever we're talking about the sampling distribution, we can get rid of all the hats. So anything with a hat is going to be wrong. So that takes care of that one. That's why C is wrong. So the answer to 92 is, in fact, A. All right, 93. Before televised debates, a poll of 800 registered voters showed 560 in favor of a particular candidate. After debates, a poll of 600 voters showed 450 in favor of the candidate. Is there sufficient evidence that the candidate's popularity has increased What is the test statistic? All right. So first off, we have p hat 1 equals x1 over n1, which is 560 over 800, which equals 0.7. All right. And we have p hat 2, which is x2 over n2, which is 450 over 600. And that equals 0.75. So that's p hat 2. But we're working with a hypothesis test. And this is where we're going to have to use p hat c, which equals x1 plus x2 over n1 plus n2. Because our formula for well, we'll start with this, x1 plus x2. Well, in this case, that's going to be 560 plus 450. And if I add that up, I should get 1100, but I don't trust myself right now. So 560 plus 450. Good thing I checked it out. Let me try it again. 560 plus 450 equals 1010. And then we have in the denominator 800 plus 600 is 1400. When I divide that out, divided by 1400, I end up getting 0.7214. All right. So our formula for a hypothesis test is going to be p hat 1 minus p hat 2 all over p hat c times 1 minus p hat c times 1 over n1 plus 1 over n2. Well, I need to plug in, and we're only going to be worried about the denominator because all of these had the correct thing in the numerator. All of them had that correctly. So we're looking for the square root of 0.7214 times 1 minus 0.7214 times 1 over 800 plus 1 over 600. And the one that has that, of course, is B. So the answer to 93 is, in fact, B. All right, moving on to 94. Which of the following indicates the use of a two-sample Z interval for a difference in population proportions? Two populations of interest, yes. The variables is categorical, yes. The intent is to estimate a difference in sample proportions. No. We're not estimating the difference in sample proportions. We're estimating the difference in population proportions. So not 3, only 1 and 2. That answer choice to let 94 is D. Number 95, excuse me, a random sample of 240 adults over the age of 40 found that 144 would use online dating service. All right. So then we have, so that case, I'm going to call that p hat 1 for just a moment, is 144 over 240. Another random sample of 234 adults age 40 and under showed that 131 would use it. So this would be p hat 2. And this is 234. Now, please remember, less than 40, over 40. All right? assuming all conditions are met, which of the following is the standard error for a 90% confidence interval? All right, so we're going to take just a moment and remind ourselves that we have a p hat 1 minus a p hat 2 plus or minus z star, and then it's going to be p hat 1 times 1 minus p hat 1 over n1 plus p hat 2 times 1 minus p hat 2 over n2. They asked for the standard error. Margin of error includes the z star. Standard error does not. So this one, and this one, B, C, and E are incorrect because they include the they include Z star. Including Z star makes it a margin of error. We want it without Z star. So in this case, and they used all sorts of squinched up fractions, which I don't appreciate because now I get to try to write it out, is 144 over 240 times 1 minus 144 over 240 all over the sample size, the original sample size of 240, plus 131 over 234 times 1 minus 131 all over 234, the whole thing over 234. Well, the one that has that is in fact A, so the answer to 95 is A. Wasn't that fun? Okay, no one said no one. Market researchers interviewed a random sample of 60 men and a random sample of 55 women. So we have two samples about the preferences for different color designs of a packaging. Of those, 23 men and 28 women preferred color design X. So P hat for the men equals 23 over 60. P hat for the females equals 28 out of 55. Which of the following is a correct test statistic for two sample Z test for a difference in proportion? All right, men minus women. So we need to find out what 23 minus 60 is. 23 minus, or excuse me, 23 divided by 60, 0.383. All right, so this is what I'm looking for. So that's going to get rid of those first three right there. So it could be one of these last two. All right. The next thing is, what's 28 divided by 55? Oh, about 51. Well, that's looking pretty good because this one has 51. In fact, it's the only one that has 51. All right. I'm going to go a step further just to remind us that the formula is, even though we know now the answer to 96 is E, is P hat 1 minus P hat 2 all over P hat C times 1 minus P hat C, 1 over N1 plus 1 over N2. So we still need to calculate P hat C to verify that this is right. We have the 60 and the 55. Don't like the way that's done. I don't think that's right. Matter of fact, I know that's not right. But the best answer, this is the best answer choice. None of them are right. This should have been 1 over 60 and 1 over plus 1 over 55, but whatever. We have what we have. So E is our best answer for this. 97. Independent random samples of voters for our two voting districts, G and H, were selected to investigate the proportion of all voters who favor a proposal to widen a road that runs through both districts. The difference between the sample proportions, G minus H, was used to create the 95% confidence interval, 0.13 and 0.47, for the population difference between the districts. Which of the following is the best interpretation of the interval. All right, so G minus H, I notice it's positive. For it to be positive, that means G must be greater than H. And somewhere between 13% and 47% prefer G to H. It's like the majority. Um, Wait a second. It's likely the majority of voters in both districts favor the proposal because all values there are positive. I kind of like that answer. All right. It's likely that more voters in District H favor the proposal than in District G. It's more likely that most voters in H, no, it's positive, so more voters than that's not necessarily true. This A is a maybe. There's some issues with it. We'll come back to it. B, it's more likely that more voters in District H favor the proposal than in District G. No, that's false. More in G favor it because it's positive, so this is false. It's likely that more voters in G favor the proposal than in H because the interval is positive. Yes, this is the only one that we can be sure of. We don't know what percent of the people favored the proposal in either one of them, but we know that the difference is this. All right. So maybe only, I don't know, let's say 60% in H, I mean, 60% in G, and it could vary between a minus 47 would give me 13 or a positive 13, a minus 13. So we don't know what group favored there. So the part that we're confident of is that G is bigger than H. All right, 98. A survey of 1,000 Americans reveals that 525 believe that whales are endangered animal and should have protection from fishing industry. In a survey of 750 Japanese, 325 believe whales are endangered and should be protected. So for the Americans, we have a p hat of 525 over 1,000. For the Japanese, we have a p hat of j equals 325 over 750. So to test at the 5% significance level, whether or not the data are significant, that the proportion of Japanese who believe the whales need protection is less than a proportion of Americans with the belief, a student set up the following P. All right. So P is 0.525 and P is 0.525. Well, we have a problem. In this case, they used a one sample. How many samples do we have? We have a survey and we have another survey. So we have two surveys. So we have two samples. So in this case, 98 is E. A two population difference for the proportions would be better. All right. 99. For a random sample of 185 children from school G, 108 indicated they wanted to study science in college. From a different random sample of 165 children, so from school G, so P hat G equals 108 over 185. From H, it's P hat H equals 92 over 165. Assuming all conditions are met, which of the following is the closest to the standard error for a confidence interval? All right, so confidence interval. Let's go ahead and write that entire formula out just to remind ourselves, even though I know it takes a little bit of time and I really would rather not. P hat 1 plus or minus, P hat 1 minus P hat 2 plus or minus Z star. P hat 1 minus P hat 1 over N1 plus P hat 2 1 minus P hat 2 over N2. The part circled in blue is my standard error. Make sure you remember that. Margin of error includes the Z star. So anything that has the Z star, we know to be wrong. And P hat 1 is 108 over 185. So really what we're looking for is 108 over 185 times 1 minus 108 over 185 all over 185 plus 92 over 165 times 1 minus 92 over 165 all over 165. All right. So really close, designed to mess you up. It has a subtraction sign. We never subtract standard deviations. We only add them. So 99 is E. All right, moving on to 100. A consumer group is investigating two brands of popcorn, popcorn R and popcorn S. The population proportion of barrels that will be popped for brand R is 0.9. So the current not kernels for the kernels that pop for brand R is 0.9. All right. The population proportion of kernels that pop for brand brand S is 0.85. So we have probably not P hat, we have P for R equals 0.9. That's the population. And for brand S, we have P of S equals 0.85. Two independent random samples were taken from the population. The following table shows the sample statistics. Yay, look at the sample statistics. This one's showing 92, this one's showing 89. So this one's a little higher, but this one is much higher. Great. So the consumer group claims that for all samples of size 100, kernels from brand R and 200 kernels from brand S, the mean of all possible differences, brand R minus S, is 0.03. And they just subtracted those two. That's wrong because it's based on the sample. We need to be based not on the sample because this is wrong. We don't want to be based on the sample. We need to be based on the population. And the population is 0.9 and 0.85. Because if we do something over and over again, if we simulate it over and over again, our simulation is going to be the population. All right? So this is our answer. This is 100. This is E. Hope this helped you all out and look forward to seeing you on the next one. Thank you.